Okay, I gotta say this is way more interesting than yesterday when I came for a dry run. I don't know what's more awkward, talking in front of people or talking to yourself with a bunch of chairs and no people. So hopefully I got that social anxiety out of the way and we'll knock it out. All right, so let's get started. Wow, I wanted to do this whole thing with a raise of hands, but there's not a lot of people who will do it anyways. We'll see what the statistics are. How many people here consider themselves a master at React? It's a React conference. I hope no, nobody? Cool. How many people, how many people consider themselves proficient in CSS? Nice, cool, amazing. All right, so this is going to be fun. A long time ago, I was a wee baby product designer, and I had an unbounded imagination for everything I wanted to do. And the first time I moved over to the dark side, where I started designing not in Figma, but in CSS, all of a sudden, everything came alive. I felt like it was the most powerful design tool I've ever used. And my static world just all of a sudden had movement. It had personality. It was able to be a little more dynamic. And the idea of, when I think about production at the time, and this is the thing that motivated me to get more into engineering, was really the gap between Figma and production. Every time I would design something, it looked golden. Every time it was on production, there was always a reason why we had to cut a corner. And I wanted to clean that up. So I got onto that side. But the power that CSS gave obviously comes at a cost. Just like any other power, it comes with complexity. CSS is the only design tool that I'm still currently learning how to center a div and feel like I constantly need to relearn that. And it's because 20 years of stacked and layered APIs, expansive mental models, and it's all just Frankenstein together. It's a core API to the web. So me and my teams, we didn't really hold back from this. We used it and abused it all the way till the bottom. We used insane selectors, variables juggled like a fucking circus act, clever property combos, doing wild stuff. And honestly, if you even took 100 Xanax and tried to reason about some part of the code base, you wouldn't make it out the other end. And eventually that became debt, and it compounded, and it compounded exponentially. And it's very, very intertwined into our state and into what we're doing on the UI. And so we kind of took a step back, and this is a long time before we got into the world of LLMs. We took a step back and we applied a really simple rule, which is obviously optimized for the junior who reads your code tomorrow. This is a common one, and the truth holds for more than just CSS. But when you really think about it, you can actually create really powerful and beautiful UIs using the most basic CSS properties and value combos. Less in direction, fewer cryptic selectors, fewer variables, and fewer derived values. It's for sure possible. We've done it a million times. And I think even the team behind Meta, that was the core principle behind StyleX, the styling library, which is to reduce a lot of the paths to get to the outcome you want and make it just much more easier to reason about. One of the funniest quotes I've ever heard about this that really kind of rings home is always write code as if the person maintaining it is a sociopath and knows where you live, right? So it's that's kind of where I go with it. So here's a very, very basic atomic example, where you can write CSS that way or that way, and over time we just favored that. This looks smarter, but this is just easier to change in the future and just know what's going on without needing to bounce around 6 files. But there's 3 main reasons writing CSS in a simple way still fails. And this can obviously be broadly applied to more than just CSS. One, CSS has a massive surface area. There's over 500 properties and value types, and you can combo them however you want. Something I think most people don't want to talk about, but it's true. Rules never serve your short-term goals, right? So when we say rules are meant to be broken, if you really think about it, in theory, best practices are nice, but in practice, ignoring these rules always serves your short-term goals, and that's why it happens on a human level. And lastly, LLMs are not intelligent. They're eager to solve anything regardless of the end state they create, right? And the discipline for writing clean CSS just eventually didn't scale. And we needed something a lot more structured, a lot more contained, and a lot more predictable, especially now that LLMs can just vomit thousands of lines of codes into your code base. So we thought about it, brainstormed, and we thought, hey, what if maybe if we had less knobs, the system as a whole would be easier to operate. And I mean, think about it. What if you took the 500 property API and reduced it down to 50? Right? What if you don't have like 100 ways to get the same outcome, you only have one, right? And the goal wasn't really to constrain the outcome, it was just to constrain the amount of paths you can take to get there. So we started asking this question, and we started thinking about it a little bit more deeper, and we said, what if we had essentially like a function that returns verbose CSS, but has a normalized API that's type-safe, and is a really, really, really small surface area? What if you were also able to get atomic CSS, collocation, static extraction, tokens, type safety, and all of it, when it's done being used and abused, it's still legible as fuck, right? What if? So the real question then became, how do you really Thanos 80% of the CSS API and live to tell the tale? It's easier said than done. What stays, what gets removed? And this is like where I was really thankful that my background was in design, because the answer was right in front of me. I think a lot of really smart people spent a lot of time and 1,000 brain cycles trying to figure out what are the most essential properties to design anything you want. And if you take a step back and look at it, it's pretty much our design tools, right? Figma, Framer, Sketch, they kind of really boil down the centralism of styling properties that you need to design whatever you want. And this moment was kind of annoying to me because it was super ironic. The tool that felt so constraining all those years ago is officially the cure to my power-chasing misery, right? So, but the inspector panel becomes a spec. We don't have to really invent what are the 50 props. We can just look at this and just steal the vocabulary designers already use. So there was the birth of Saucey. Saucey, the whole API is actually 40 properties across three mental buckets: frame, layout, and text. Frame, as it implies, deals with everything that styles self. So this includes width, height, corners, fill, border, padding, overflow. Layout deals with everything that positions the children. So flow, gap, align, wrap, columns, rows. Text, I'll leave that to your imagination. And this is the entire API. These are the only keys you have, and you can stare at it for like 5 seconds and realize that everything you'd want to get out of it, you'd probably be able to do. So we started with this, and the main reason why we called it Saucey is actually quite funny. We called it Saucey because every good Italian nonna will tell you that a great sauce only needs very, very few ingredients. The way we went about implementing this, we started off with the DX, the developer experience first. Above all, we wanted to aim for two outcomes. We wanted whatever gets created to be legible, and we want whatever gets created also to be super constrained. So really, really hard to break conventions. Desired outcomes become deterministic and not a weighed probability that you constantly feel like you're playing whack-a-mole with a skill. So we started off by designing the API in TypeScript, just making sure everything felt right with zero implementation. There are two main bets that we made around how we get to success. And first, the insights were, humans have an easier time thinking in hierarchies, which is not really honored in CSS. You have a very flat API. So we looked into how can we do this in progressive disclosure, and I'll kind of explain what this means in a second with an example. Second, humans have a really, really hard time focusing, just like LLMs, when there's a lot of distractions. So there comes the birth of abstractions. We're used to them. Try building an entire app in vanilla JavaScript and then tell me how much you hate React, right? It's much, much harder. So we looked at both, and here's an example of progressive disclosure. When we look at the API inside of frame, we have a key that's called fill. If you give it a background color, it's a background color. If you give it an array, it's going to give you a gradient. If you inverse the order of the array, it's going to give you the inverse gradient. This is just a very quick way to do it. If you give an array of objects, you can actually stack a gradient on top of an image, and you can put a nice little black gradient on top of the image, something that we do a lot, and it's just really easy to read. A lot of times, like when we looked at the API, we were actually not really concerned about making it terse, making it as short as possible. We wanted it to be as legible as possible, which I feel like even if you're looking at the last example for background, you need to remember in CSS what position every key's in to remember what it does. Here we take out all that cognitive load, and LLM's going to write it, and you can just scan it, and you know exactly what's going on. And this just makes it really, really friendly to reason about. And this is what we liked to call progressive disclosure, and we did this for like all of our APIs, right? So at first it's like really simple, and you can dive in to more complexity, and we heavily leaned on TypeScript's discriminating types to give really, really good type safety. So as you go into different branches and options, types get updated and validate based on where you're at. So essentially, like if you're creating a linear gradient, there's no position key inside of that object, and it knows that, and it'll throw you a warning if you try to put that there. Another example, which from the other side of abstraction, we restricted a lot of APIs and we merged others. So for example, align center, we stole the idea from Figma of like, we just have a 9-point grid. You don't need to think about the axes you're on or any of that. You don't need to think about the difference between justify and align. And wow, it still feels like itching my ear this way when I think about it. You just say center and it goes there, or you say top left and it just goes there and everything just works the way you want. Also, everything that is directional under the hood, this is something that a lot of people don't do and hate themselves later for not doing. They use physical properties, so that's like margin left, and logical properties is margin inline start, right? When you use logical properties, if you ever switch between right to left and left to right, everything updates automatically. So for us, we code left to right, just normal. We normalize that whole thing. But under the hood, we're actually using logical properties. So everything inverses. If you stamp the top DOM element with the right to left, everything updates properly, and you don't have to think about those things either. So we abstracted a lot of concepts, even for internationalization. Another example is gap, right? So essentially, inside of Figma, you can do this, and I've always liked it. It's a really good feature. Gap, if you set to auto, it does space between. Obviously, that doesn't align with the 9-point grid, but you have a way of doing that. Another thing that I always really hated is, like, if I want to get 3 avatars to overlap each other, that's a negative margin. But essentially, I just want it to read as a negative gap. So we even route to different CSS properties under the hood, but normalize the API on the surface, and it's just easier to parse, easier to read, and easier to reason about all in all. So here came like the hard part. Once we had the blueprint for what we wanted this thing to be, we understood that there's a lot of plumbing that you need to deal with to handle CSS and JS, right? If you want tokens, collocation, static extraction, atomic CSS, all of these things that we take for granted when we use Tailwind, we use a bunch of different libraries, these are really, really hard things to build for, and we didn't want to maintain all of this stuff. It's hard to build, it's hard to maintain, and we just wanted the thin normalization layer on top of it. So this is where Panda CSS comes in. Panda CSS seemed like the right answer for this because, as a primer, the way Panda CSS works is you get a CSS function, and it will do this at build time, right? So you just write object syntax CSS, you get that, you get the type safety, you can use your tokens in that function, all that's great. And pretty much the way it works is it like scans your code base for CSS call signatures, it looks inside during build time, and it generates your CSS file. This is a lot of like how Tailwind also works. It's a just-in-time compiler. Now, with Panda CSS, you get all of these features. You get tokens, you get collocation, you get type safety. Now, all we needed was one small modification. We asked, what if we have the CSS function, we have 3 special keys, but more than that, you have the escape hatch. If you want to write manual CSS and you just need control over some crazy API for whatever reason, you can just add it right then and there, right? So most situations, you're writing Saucey CSS, and then after that, if you want to reach for something really, really specific that you're just not going to get from us, you can always do that as an escape hatch. So this was like where we saw the vision, and Panda CSS actually has a very, very, very straightforward way to doing this. They have inside of their config a hooks API. It's not React hooks, but it's a similar concept. They have a first-class citizen feature for being able to latch into their compilation step, right? So you don't have to do anything complicated with Vite. You can latch into their compilation step. They have an event that's called parser before, which as it reads, it allows you to run whatever function you want before they parse your code base. So essentially what you're doing is you're taking the code base and you're parsing it, and then you're transforming the Saucey keys into valid Panda CSS, passing it along, and it deals with the rest. Token resolution, static extraction, everything else, right? So essentially, this is what it looks like, right? So inside of your config, you just write a transform. The transform, we use TypeScript library to do it. So TypeScript ships the library that they use to compile TypeScript. I think this is like really, really powerful library for overall processing JavaScript, understanding code, and doing stuff to it. So we use that under the hood to scan our code base and just look for the keys. And ultimately what we're doing is we're finding the keys and we're returning something that's just kosher Panda CSS. So that's essentially what's happening, right? Everything else we get for free. And all of this has no weight on runtime because all running at build time. What does a post-Saucey world look like, right? So first, wrong is officially a type error. A rule is a skill that kind of asks the model to behave, but a tool, its types kind of remove the ability to misbehave at all, right? So here it's like docs are really a suggestion, but CI is a contract, and we heavily wanted to lean on TypeScript for this. And we control the entire type API. Designers can review code. This is one of the biggest things. I am a design engineer. I've come from a background of product design into engineering. And when people ask me the question of should designers push to production, absolutely not. I'm a big proponent of understand the material you're working with. Don't ship slop to the code base. If you don't understand it, don't touch it. But one of the things that we started getting as a benefit with all of our clients and all the code bases that we've deployed Saucey into is engineers are able to send code snippets to designers, and because it reads like the Figma inspector, they can say, oh, I see why you're getting the wrong shadow, just adjust this, do that. It looks exactly like Figma, and it talks the same language as Figma, so that collaboration went up significantly. You can tweak it. When you take 500 properties and you bring it down to 50, all of a sudden, the output that you get from LLMs is very constrained. A big part of design working right is the ability to tweak that 80% result you get from LLMs. But if you can't find the source of where the padding problem's coming from or where that styling issue is, you're not going to make that adjustment manually. And a big part of being able to just get it over that line is being able to reason about the code, make that quick adjustment. It's way faster versus being able to like run Claude Roulette and just say, oh, this is off, and it changes that, but it also adjusts a bunch of other things that were completely stable and fine. So in our world, you're able to actually reason about the code. You're able to read it, find it, and also tweak it manually, which I can't say enough how important this is in a world where LLMs actually don't have eyes. Everything in our code base stays consistent, right? So every value comes from the design system, tokens, nothing drifts, even after thousands of LLM generations. What's my biggest takeaway from the way we brainstormed this and how we got to it? We started off with a simple principle of like tools before rules, and we also wanted to be super bullish on preventative care versus reactive treatment. A lot of times I find that a lot of companies are constantly playing a game of whack-a-mole of trying to get LLMs to behave versus remove the ability to misbehave in the first place. And a big part of doing that right is looking at your core tools and trying to figure out, all right, this tool is made for the general public. It's meant to be used in 100 different ways. But if we're only using it in 3 ways out of that 100, how do I force a convention so it doesn't use any of these other stuff, right? And taking that all the way to your state manager, the way you write styles, all this different stuff, it becomes a much smaller surface area for an LLM to layer on top. And this sets a massive stage for us. Now that we've done this, both for styles, we did this for state management, we've done this for internationalization, we've done it for a lot of core problems that we're constantly trying to solve. Now we're setting a stage for designers to feel at home inside of a code base. I'm not saying all designers are going to make it there, but definitely code-curious designers are having an easier time coming in. Agentic workflows that feel significantly more deterministic because they layer on top of this. And humans stay in the loop stress-free. I think this is like where the biggest problems happen is like the second it just gets too wild, you start surrendering control over what's going on, that over time erodes, and then you're in a situation where every feature you ship 9 break, and that's already, the durability is kind of lost. Anyways, I'm Didi Medina, I'm a design engineer. I'm a tooling architect. I run a studio called Do Studio. We help product teams tune their front-end toolchain so LLMs can run wild, and humans are not stuck cleaning up the mess, and hopefully customers get the value of that outcome. If you're interested even to the slightest about developer experiences, taming LLMs, or even product design, which I'm probably the only one here on that, like, feel free to come grab me. I'd love to hear from you. Thank you.